Hello and welcome. In this video, I will show you how I measured the change of daylight factor of a pergola with swivelable blades. According to the European 17037, the daylight factor is defined as the ratio between the internal illuminance and the external illuminance. The measurements have to be taken under some specific conditions, such as the position of photosensors and sky condition. To do the experiment, I made both internal and external photosensor circuit using the Arduino, and I brought a luxmeter to calibrate those photosensors. The internal sensor sends data to the external sensor through a radio communication. The external sensor combines both data and sends them to the computer through a serial communication. So I can place freely the internal sensor inside the pergola. The photosensor I used is the so-called LDR sensor, which stands for Light Dependent Resistor. With the Arduino's ADC, I read output voltage of a simple voltage divider. The datasheet of the sensor tells that there is a linear correlation between the logarithmic function of the illuminance and the logarithmic function of the resistance, and that will be our reference for calibration. I took for different levels of illuminance the values given by the luxmeter and both sensors, and then I inserted those data into a Python code to see the plots. The correlation is perfectly linear. Now, with a simple linear regression, I get the illuminance value from the sensors. Now I put my external sensor outside the pergola and the internal sensor inside and launch the experiment. I designed a graphical user interface using Python and Qt Designer module for managing and representing data. I launched the experiment, and this graphic represents the results. The experiment shows that the daylight factor reaches a value of 39% when the blades are in a vertical position. I did again the experiment on different points of the pergola, and I made a 3D representation of the evolution of the daylight factor. That's all for the project, and thanks for watching.